Okay, this is the mission 58, organized by Space Analog Station Habitat Marte. And today we'll have the presentation about the main station, how would be the operation of a main station based on Mars. And then we have some topics that we'll be discussing during this presentation. And then if you look if you look the blueprint of the Mars habitat, okay, uh, then it's possible to see some possible locations of different facilities of our infrastructure in a Mars habitat. In this case, it's possible to see the location of the main station, okay, close to the health facility, the launch center, and greenhouse. Uh, our presentation will be discussing main five dimensions, and then the first dimension is about the internal design, okay, and then here we have some proposals done by Yash Rato from India, okay, but we are presenting a new idea about the main station because the main station is a facility where we have the beds for all astronauts. It's like a place that all astronauts become together during specific times by day. Okay, and then in this case we are imagining the beds for everyone, and then in this design is not considered the beds for uh, a crew uh, with members around 25 or 30 members in this mission, okay, and then in Mars. And then in the main station, we are imagining some facilities like the control center. This control center is responsible for management and communication. Also, a big door in the main station. Also, training room, dining room, kitchen, and one area, one recreational area. Also, the research room. Also, the small vertical garden with plants for meals. And then we can see some concepts that how would be the operation or how would be the design of these infrastructure, the main station. Something important would be the not will be like this, but something that I like to consider is the importance of we have some plants in the inner area, okay, because the plant is also interesting by many reasons. The plants are important to see how the quality of the air is operating. Also, the is important to bring some environment ideas for the crew. Okay, and also is a important element to bring some uh, peace state of mind. Okay, and then the control center is we can see a lot of screens, computer screens. These computer screens would be used for multitasking skills, multitasking activities. Okay, and then if you see the panels aboard the Dragon capsule, you can see the screens with multi activities control. Okay, and then this is the concept to be used in the computers aboard of the main station and the control center. Okay, and something interesting that we imagine in the main station is the operation of a dashboard. Okay, uh, it's a dashboard, okay, and then in this dashboard it's possible to see some utilities, okay, like the greenhouse, the power station, okay. It's possible to control many dimensions of the operation of the habitat Marte, okay, the Mars habitat, okay. In this case, in the main station, they will have the control about the greenhouse, the power station, indicators, and health data from the astronauts, and also sanitation elements, okay, aspects studied, okay. And then it's possible see also is important the operation of a research room. The research room is also collaborating with engineering center doing some analysis from sometimes would be analysis of the soil sample, the regolith, sometimes would be the biological samples from the astronauts, and also research room is also collaborating to with the health center, okay. Also mainly in a first moment of the Mars exploration, the research room would be very important for the uh, first missions based on Mars. And then the dorm is something is very minimalist, the dorm, and also presenting areas to keep the personal clothes and something like this, okay. And then the kitchen, we are considering the production of some vegetables, but in small quantity, because we are considering the greatest part of the food production is based in the greenhouse, okay. And then this is important, but these are just some spices to be used in the food, like basil or other spices to be used in the food, okay, and pick and eat, okay. And then this would be interesting element. Also, we saw a startup. The name of this startup is Molly, and then you can see in this photo a robotic arm. Sometimes this robot is looking the labels of the food, and also based in machine learning identify the labels, and deciding about what kind of element will be added to prepare the meal, okay. And then this robot would be a very interesting support to the kitchen, okay. Also, if you see in our left, there's a like a screen. Then in this screen they would have like videos with explaining the preparation of some kinds of meal, and then I believe this would be very interesting. Also complementing the process of meal preparation, and then also uh, possibly having some connection between the instruction and also the procedures developed by the robot, okay. And then this is a technology that is also just commercialized, okay. And then it's interesting after see the website of this company called molly.com. And then the dining room is not so big. In this case, we are looking some turns for for each time you have like maybe eight astronauts for during each turn to be eating. Okay, and then also the gym, an area very important to keep the very important to the health of astronauts aboard in this station. Then we had a discussion with a Brazilian architecture student. Her name is Mariana Guerra, and then she proposed not one habitat, but three habitats connected. And then the name of these three habitats, these three models, would be the alpha, beta, and gamma. Okay. Okay, and then the proposal is the alpha model is for prolonged use. Okay, just, my dogs are barking just a moment.
Hi, Rachel. Good evening. Hello, Ilan. Yeah.
Okay, I'm sorry about. Okay, just a moment. And then the alpha model is for prolonged use and for resting. The beta model is for medium use and leisure. And then the third model is gamma, is for the work. Okay. And then in the alpha model, we have the bedrooms and the study room. In the beta model, we have the kitchen and dining room and living room. In the gamma model, we have is an area for training and control and research room in the gamma model. And then alpha model, we have the 13 bunks. And then in these in these bunks, we have also area for luggage storage and also bathrooms and also study area. In the second, the beta model, we have kitchen, dining room, and also in the second floor, the living space and also the gym. And then in the third model, we have the research room, training room, and control center. Okay. And then, yes, and then some applied technology to be operating in the main station. We are imagining the oven, the fridge, the virtual reality red sets, the spa hydro message, the also disco lighting, also communication technologies and antennas. And then all of these technologies will be aboard of the main station. And then in the beta model, okay, would be important to some recreative activities like parties, okay, sometimes uh, to not be boring the mission in based in Mars, okay. And then in terms of the discussions of related to the materials to be produced in Mars and also transported from Earth, we imagine that almost everything will be transported from Earth, okay? But part of the food will be produced in the greenhouse. About the third dimension, we will be talking about the management, and then we imagine the four positions: the commander, the executive chief, the chef, and general assistant. Okay, and then the commander is the he would be presenting a multidisciplinary background, and then would be someone with management or industrial engineering bachelor with a high capacity of leadership and high personal resilience. As some duties of this position is the control of the extravehicular activities and the use of the rovers and the vehicles. Okay. Also, this activity integrated with engineering center. Also, this in this position, he or she would be proposing routines and operational protocols, providing guidance, also conducting the educational activities, preparation for EVAs, coordinating daily communication routines with NASA, ESA, and ISRO, and other space agency with mission control centers. Also communication with facilities, with the crew, and also with specific individuals, okay? And then the second position is the executive chief. We suppose that this person would be an engineer or someone with information technology background. Some duties are the monitor all operations, keep all facilities running, monitor the routine maintenance, organize the specific operation as responsible people, coordinate trainings, also keep all facilities running, organize the specific operation, stimulate self-sustainability. Each one observes self-organization, self-maintenance, self-fixation, and alerting others. And then the chef is someone based a cooker or a cuisine chef, nutritionist or gastronomer. Some duties of these positions are define meals and food logistics, perform food preparation, waste disposal, cleaning, uh, organization, maintenance and repair procedures, assess the team's nutritional requirements, plan the availability of food, and define the feeding shifts. Okay, and then in the first picture here in this slide, we have the character Neil or Thomas Anderson, uh, interpreted by Kenny Reeves in the movie The Matrix. And then in this photo, Neil is aboard of the Buccaneer ship. Okay, and then he's eating the oat. Okay, every day he's eating oat, and then he is complaining about the meal, saying that all days is the same food, it's the same meal. And then it's interesting metaphor because in the Mars habitat, the food need to be very diverse and very different each day, and then the meal must be something fun that presents fun and challenge related to the meal. And then the chefs need to be someone very creative in terms of proposal uh, interesting meal for the crew. Okay, and then because of this is very interesting, we have different kinds of fresh spices, and then it's very interesting to be considered by the greenhouse because if you see in the next photos, we have the astronauts meals. Okay, inside the plastic package. Okay, and then in Mars they have something that like they are putting the hot water inside the these plastic bags. Okay, plastic package, and the hot water turns it permits the meals recover the same qualities. Okay, because it's dehydrated and then is becoming hydrated. Okay, and then this is a interesting thing to consider about the meals transported from Earth. Okay, and then, but in Mars, part of the meal will be produced in greenhouse. Then in this photo, the last photo, you can see the lettuce, pepper, okay, like small pepper, and also basil. And then the meal to be prepared in Mars will be based in the food based in prepared and transported from Earth, and also the food produced in Mars. And then will be a balance between these two possible sources. Okay, and then also is very important to the safety of the mission in Mars, because if you have a problem in the greenhouse like explosion, uh, also share it in the Mars series in Netflix. They have the meal transported from Earth. Okay, and then there's also a danger become very dependable of the resources transported from Earth, because if it happens a problem, they with the during the rocket travel, they also need the food produced in Mars, and then this very delicate balance between the food produced in Earth and also the food produced in Mars. And then the last position is the assistant, would be someone, engineer or information technology technician. Some duties are this person will be emphasize the well-being. Okay, and also developing the interesting content to entertain the crew. You'll be also dealing with food management, support the chef, coordinate the organization of the dormitory, they coordinated the gym, also managing the laboratory tools, the study routines, also applying surveys with the astronauts, psychological surveys. And then some topics of training, the new skills based on situations identified in Mars, also system operation, testing, training of new technologies, training about the position, specific tasks, and simulations. And then here are some videos about the teams work, also mental health, also I shared a link about baroque music, okay, and also occupational safety and health, and about building resilience. And then there's a lot of interesting videos to be considered to be used in the training of the astronauts, and also have some entertainment. And then also some topics about the resource necessary for 1 week, and then we are considering 1 kilo by day of of water, sorry, 1 kilo of food, sorry, and then also 2.5 liters to prepare the 1 kilo of food, and then also 2 liters to for bath of astronauts. And then some guidelines to be provided to other facilities are related to mental well-being and entertainment, also daily routines and scheduled activities, health occupation, also related to the health environment safety guidelines, and also how to maintain plants in specific space habitats, provide harmony and collaboration, make astronauts comfortable about to be in space, stimulate cooperation, innovation, creativity, co-creation, emphasize the team's well-being, creating interesting content to entertain the crew, also stimulate self-sustainability. And then the fourth dimensions are the protocol. Then we imagine protocols for relationships to deal with stress, to organize the room, also plant maintenance, food production, also protocols for maintenance. The protocols of safety are related to hygiene protocols, wearable data collection protocols, examples, use of Apple Watch, heart rate, calorie consumption, physical activity level, saliva, blood, feces, and urine samples. This would be connected with the health facility, okay? Also protocols for to deal with the psychological emergencies, protocols to deal with accidents, and then the protocol for occupancy is related to the some activities related to parties, celebration day, spa day, board games, yoga, physical exercise protocols, reading and content suggestions. And then this is an idea of the vertical garden, how it would be operating, like a circular system. And then in terms of the protocol for micro food production, uh, we are considered a protocol for cultivation, protocol for maintenance and detection of adjustments, and management of the plants, food collection, protocol for rotation disposal of the plant, also considered the best time for irrigation, male female flower pollination, uh, also talking about the plant cycles and plant lifespan. And then we are considering related to the 3D printing. We are considering some protocols related in this image. They are printing uh, a ball, okay, something like a ball. And then we imagine that it is maybe possible in Mars. They use the regolith or create a composting material to be used, and also to be to create a material like a clay to be used to print some materials and some utensils to be used in Mars. Okay. And then so protocols for 3D printing. It's necessary printing the utensils to be useful to print utensils like plates and mugs. Okay, and then it's very important to have a list of CAD files to print these projects. And then it's very important to a protocol related to the product degradation, like crushing the discarded items, preparation of pallets, preparation of filaments for 3D printing, and the 3D printing process. Okay. And then some spin-offs, some technologies to be applied in Earth is is the 3D printing applications, I believe. Okay. Uh, Related to guidelines to be applied in daily life on Earth, we can see the some guidelines related to mental well-being, daily routines and guidelines, health occupancy, also health environmental safety guidelines, and then during the time of pandemics, we saw some lives of astronauts talking about how they live in the isolation international space station, and then we believe that this kind of presentation would be useful to be shared in earth. Okay, they commenting how they are developing scientific experiments, and how they are developing the daily routines. Then I believe this kind of things is very interesting to be shared on Earth. And then some impacts to sustainable development goals. You can see the impact about the good health, because it's very important the astronauts be very healthy, because if they are becoming sick, it will be very difficult to treat in Mars, because it's a very big journey to bring this person back to Earth to be treated here in a hospital, and then before a astronaut become ill in Mars, they need to have all the attention. Because of this, it's very important the health exams, the very constant health exams, because one of the greatest worries in Mars is related to the Mars dust, because the Mars the particles of the soil would be is very sharp and would be contaminating the respiratory system and bring some problems to the lungs. And then also other big threat to the health of astronauts are the cosmic radiation. Okay, and then this very disturbing. Also, the third important elements are related uh, to the psychological elements, because the astronaut will be very isolated from from the family. One moment, I don't know, I believe it's a video. Yes, okay. And then it's very important the discussion about the health. Okay, the health of astronauts. The second one is very important, the discussion about the quality education, and because we are dealing with research. The third dimension is the discussion about the gender equality, and then it's important the human participation. And in the main habitat, we are dealing with we're generating a lot of sewage, and then you need to think how to treat the sewage. This is also connected with the uh, sanitation center, and then also thinking about the energy efficiency, and then also the goal 15 is related to recycling, and then the 16 is the partnerships, because we are dealing with participants from many different countries. The also the 17th, and then the 16th is the 16th goal is related to the management of the station. Okay, and then we consider the main station is connected with all of these uh, sustainable development goals. Okay, and then these are my contacts. Thanks so much for your attention.